Okay, so the last part of Unit 9 vectors is going to be the word problems. So, Unit 9D vector word problems. Okay, so the scenario is this: a hiker bikes away from the base camp heading due north 6 kilometers. So, this is just the displacement, it's not velocity, it's just how much of distance is it from where he started. So, if the base camp is there, it goes 6 kilometers north. At this point, he's here at the arrowhead here. That's where he's at. Then it says that he runs 8 kilometers east. So he goes this way, 8 kilometers. Then he skates 12 kilometers south. Okay, so he goes down this way. Exhausted, he radios to base camp to come get him. Which way and how far do his rescuers have to go to get him? So he's over here and camp's over here. Um, it wouldn't be a good idea. It would be he's not gonna tell them that he went that way up that much and then that way that much and to go get him go this way. The best way to do it is if he can somehow some way say that and figure out what is the distance between the camp and where he's at right now. And so this is what we want to do, give a distance directly to it with an angle with respect to the horizontal would be another way of doing this. So what is this distance here? And that would be a much quicker way to get to him. The angle here would be also what we want to know. So here, what I've done is that we need to make a right triangle here. And the reason this is 8 kilometers is because this is parallel to this horizontal displacement. So if this is 8 kilometers, we want to figure out what this is before we can figure out what this hypotenuse is, because this is a right triangle. So since I know it went up 6 and then it went down 12, the difference between them is 6. Okay, because 6 plus 6 is 12. So this right here, from here to here is 6. Basically, what we really needed was this right triangle here, the resultant. So let's get rid of the rest of that. And so to figure out what that vector here is, or what the direction, the magnitude length, or in other words, is just plug in. It's actually the Pythagorean theorem. Just plug in x is 8, y is 6. Work it all out. It's going to be 8 squared 64 plus 6 squared 36. 64 plus 36 100. Square root of 100 is 10. The displacement is 10, so the distance here is 10. The angle here we can figure out by doing tangent inverse. Theta is going to be equal to tangent inverse of the y over the x. Tangent inverse will be 6 over 8. When you plug this into a calculator, it does give you a positive number just by the way I wrote it down, because 6 over 8 is positive, so it's going to be in the first quadrant. But you should know that it should be, if you're going negative, it would be a negative from the horizontal, but it doesn't matter because you could just say 30, what is this, 37 degrees, but all you have to say is the direction, and the direction seems to be southeast. So as a summary, what you would say is when it says which way and how far do his rescuers have to go to get him from base camp, they would have to go 10 kilometers at a 37 degrees southeast direction. Problem number 2, you got a pack of 3 Arctic wolves fighting over the carcass. Carcass right in the middle. You got 3, these ones are the forces. Top view of the magnitude and direction of the 3 forces shown in the diagram. Determine the resultant or the net force acting upon the carcass and the direction of the movement. So this wolf's pulling this way, that one pulling that way, this pulling down. these ones are in line with the x-axis, like this one's on the x and this one's on the y. The problem would be here in order to find the resultant force. What I'm going to do is find all the x, a resultant x force and a resultant y force. Let's do the x, horizontal net force. So I know that it's going left 300 units. So it's going in on the left 300 units. You could even say it's negative 300 newtons. This one would be going positive, I guess, on the x. You could say it's going to the right. So we want to know the x component of this 420 newtons. And that would be, the x component would be 420 times it by cosine of 30 degrees. That would be the x component of it. And so that's 420 times cosine of 30. So in this situation, you want to figure out what 420 times cosine 30 is, and that is about 364 degrees. So what you do is, since this is going in the negative direction and this is going in the positive direction, right, you basically subtract 300 from 364, and that'll give you the resultant force. And the resultant should go right because there's more force here than there. So it's going to be 64 to the right. Let's find the vertical net force. We already know it's going down negative 250 newtons, so that's going to be negative. And this is going to be positive going up. It's going to be 420 sine of 30. So it's going to be 420 times sine of 30, which if you put in a calculator, should be 210. So it looks to be that the down force is bigger than the up force. So it's going to be negative 40. Okay, so when we do this, this should be a negative 40 newtons, but in reality, it doesn't really matter when we do this, finding the resultant force here, because you're going to have to do a quadratic, not the Pythagorean theorem for it. So this is going to be the vector, the magnitude of the force is going to be the square root of 64 squared plus 40 squared. Work it all out. It turns out to be 75.5 newtons. We want to find the angle here. You just do theta equals tangent inverse of 40 over 64. Again, you know that the direction's down, southeast, you could say. So whatever the angle you get here, which is going to be positive, is still okay, as long as you say it's southeast. So you're going to say 32 degrees southeast. To summarize, determine the resultant or net force acting upon the carcass and direction of the movement. So the net force is 75 newtons at an angle of 32 degrees southeast.